this is a big question. What we need to measure as a matter of the fact. So before we ask how to measure, you need to know this part. The literature covers three categories. The first one is physical, then psychological, and comfort. So why these three categories matter? First, physiological parameters, we have factors such as heart rate, body temperature, blood pressure, respiration rate, oxygen saturation, electrocardiogram. And these are the vital signs that we can find in an Apple Watch or a Fitbit. Then we have physiological parameters. We have factors such as electrodermal activity, stress indicator, depressive symptoms, fatigue signals, cognitive load proxies, and sleep quality. This is where the maritime context get particularly interesting because seafarers have a lot of mental health issues. And this is one of the factors that is mostly under monitored in the industry. And the third category, sometimes, it's overlooked, is comfort. Like thermal comfort, vibration comfort, postures and ergonomics, motion sickness proxies. These also matter because seafarers who is uncomfortable for 12 hours in a seafarer, this person is going to degrade his attentions, and the error rates could climb, as a matter of the fact. So one of the biggest problems that we will have is that consumer wearable fails in maritime conditions. We have devices that works perfectly in a gym here in Mexico City, but the same device will fail within days in the North Atlantic at sea. So the literature is clear about these facts. Design requirements are really important at sea. We have requirements such as waterproof. It has to be not splash resistant, but actually the device should be waterproof, surviving immersion. We have also MII resistant. So it needs to be immune to the electromagnetic interface from ship machinery, which this kind of interface is constantly and intense. Also, it should be vibration tolerant. Engines and waves transmission, continuous mechanical shock. Also, long shift comfort, 8 to 12 hours of wear without skin irritation, low power because, charging access will be limited, and corrosion resistance against seawater. So one of the most promising development here is optical fiber sensing. Optical fibers are non-metallic, so they don't corrode. They are immune to electromagnetic interface, and they can be embedded in textiles for comfort, long-term wear. So several research groups are now exploring optical fibers as the next generation of marine wearable substrate. So we will take a look to one of the first studies. Let me bring this to you. Daniel and colleagues at the University of Kuala Lumpur published in 2024. This system that is actually a simple system is based on an Arduino Uno microcontroller, and it's based on there's thermistor for body temperature, a pulse oximeter, and a ESP module with Wi-Fi. And this is all connected to a Blinkout platform. So what do you think about this? It's about like $50 in components total amount. And this could monitor 10 seafarers across a single day at a 4-hour interval. So what they found, an average resting pulse rate of 77.8 beats per minute, squarely in the normal adult range. But here's an interesting fact. A consistent midday elevation about 2.4 beat per minute across the group, attributed to the workload and postprandial effects. So also, body temperature average 36.7 Celsius, with one subject showing 0.3 Celsius postprandial rise. But here is an interesting factor about all this kind of information that they get from this kind of device. Um, and this is particular for the industry professional in the room. You don't need, like a $10,000 dollars device to start surfacing, action patterns across the seafarers. What you need is a good interpretability, and also cheap sensors with good analysis can be the expensive sensors with no follow through. This study makes a point about conviction and how you can challenge all these kind of factors that you need to come across. So here is another study, the offshore diver problem. Barbosa and colleagues at the PUC-Rio in Brazil University set out to build a waterproof signal device for professional offshore divers. So, diver is a challenge. The first part to analyze is that divers, wear a helmet. So you can use a air clip oximeter. The diver use both hands constantly during work, so finger sensors are not an option. Water movements defeat sound-based measurements, so auscultatory blood pressure won't work. And here is something that also matters. Bluetooth signal does not propagate through water, so your wireless system, the foundation of every consumer wearable device, simply won't work. So their solution is actually is nice. A chest belt with an all sensor localized to the torso. So heartbeat, RR interval, temperature, and inertial measurement units. Communication uses an RS-485 protocol over the umbilical cable that already connects to the diver to the surface. So they iterated to 3 controller platforms. They have an Arduino Mega, a Raspberry Pi, and a SP32. Settled on the SP32, they have a low consumption Bluetooth system for support. The insight here is like, diver context in maritime environments, wire transmission often beats wireless. So the medium of transmission have to be chosen for physical of the environments, not assumed for the consumer engineering. So in this lesson, it was better to have a wireless transmission. So this is this study. So for the next one, this is our third case of a study. Okay, so we are referring to the sensing space. Wang and colleagues published in the ACS Applied Materials and Interfaces in 2022. They ask a question in a different way. How do we monitor each person is, the normal way that we will take a look to a problem, but instead they ask the following question. How do we monitor each space? So the solution in this, they put a triboelectric smart mat at the doorways of cabins. In this place, seafarers walk across the mat. The friction generates small electrical signals, and that signal carries the unique signature of the person walking gait. So they train a convolutional neural network over 900 samples from 9 users and achieve a 94.44% identification accuracy. Why is this identification accuracy important? Like first, you have privacy. There is no cameras, no body attached devices, no continuous biometric STEAM. Second, multifunction of the data. The same system can identify a person, count people in the cabin, and locate them on the ship. Third, it is self-powered. Like triboelectric means there are no batteries to maintain the system. And fourth, the operational uses are immediately. You have epidemic control, emergency headcounts, and access control. So for the students in the room, like this is a new way to approach a problem. The dominant paradigm says always measure the person, and they approach this problem by, like let's measure the space and let the person walk through it. So this kind of reframe of a problem is often the most interesting research, outcomes for me.